Hey students, this is lesson 6.1, solving systems by graphing. In this lesson, we're going to learn how to look for a common solution of two equations with two variables by graphing. All right, go ahead and do the review here. I'll check back with you. All right. First of all, let's talk about what a solution of a system of equations is. What that's saying is that there's some x and y value that makes this equation true and this equation true at the same time. So in one way we can locate that solution is by finding the point that the graphs of the two equations have in common. So I'm going to graph 2x minus 1, and you can graph it this way if you want. I'll do the first one like this. So let's just pick a couple values for x, 1, 2, and 3. Remember, we only need 2 points to graph a line. But if I put in 0 for x, then I get negative 1 for y using this function, 2x minus 1. And then if I substitute 1 in there for x, I get 2 times 1 is 2 minus 1 is 1. 2 times 2 is 4 minus 1 is 3. 2 times 3 is 6 minus 1 is 5. And so I get points like 0, negative 1, 1, 1, 2, 3, and so on. And once I have a pattern, I can continue that pattern and draw the line in. So there's my graph of y equals 2x minus 1. Now to find the other one, I'm going to do this one a little bit differently. I'm going to just use my slope and y-intercept to do that. So my y-intercept is negative 7, so I know there's a point at negative 7, which is just a little bit off this graph. So I'll just put that point in here. So 0, negative 7. Now I'm going to use my slope, which is 4. That means every time x goes up by 1, y goes up by 4. So adding 4 to negative 7 gives me negative 3. Adding 4 to negative 3 gives me positive 1. So if I go up 4 and over 1, I get points like this and like that. And now if I draw that graph in there, through those points, I see that it appears like these two equations are intersecting right there at that point, which is 3, 5. So I think, and when I write the solution like this, what I'm saying is x equals 3, y equals 5. So now just to check that, I substitute the values in the original equation. So x is 3 and y is 5, and just make sure that's true. And 2 times 3 is 6, minus 1 is 5, so that one's true. And then the other one, we're going to substitute 3 and 5 in for x and y again in this equation. So I'm going to do 4 times 3 minus 7, and y has to equal 5. And 4 times 3 is 12, minus 7 is 5. So it works there also. All right. Go ahead, you try and find the solution here. All right. Suppose one puppy weighs 5 pounds at birth and grows at a rate of 0.25 pounds per month for several months. Another puppy weighs 4 pounds at birth and grows at a rate of 0.5 pounds per month. After how many months will puppies weigh the same weight? Well, we can see this on a graph if we just graph each of these ideas here. And one way I can do that is just make an equation. Let's say that y is the weight of a puppy. At birth, they weigh 5 pounds, and the first one grows at 0.25 pounds per month. Let's let x be the number of months. And so that represents the weight of the first puppy. The second puppy gains weight at a rate of ½ pound a month and started at 4 pounds. Okay, and now when I graph this, I'm just going to use first quadrant points. So let's say, let's just go by, I don't know, half months. That should be good. And then the weight, we can just go by ones on our weight here. So this is the weight, and this is the months. And we'll just go by one, so 2, 4, 6, 8, 10 pounds. All right, so one of the puppies, the first puppy started at 5 pounds, that's right here, and the weight went up by a quarter pound every month. Now, a quarter pound will be kind of hard to do, but I know that if it goes up 0.25 pounds in a month, in 4 months, it would go up by 1 pound. So I'm just going to skip out here 4 months. Actually, I'm going to change my scale. See that I should just go by single months. All right. So every 4 months, this puppy will gain a pound. So that will look like that. And I can draw a line to represent that puppy. Right there. Okay, and then my other puppy is starting at 4. And that one gains a half a pound every month, so in 2 months it will gain a pound. So that'll look like this. And I'll draw a line in for that. I'll change my line color for the other dog. Red line there. All right. And I can see that right here, they both weigh the same amount, and that's after 4 months. So we can answer this question now. After 4 months, they will weigh the same. All right, you try that. All right. System of equations that has at least one solution is consistent. A consistent system can either be independent or dependent. A consistent system that is independent has exactly one solution. A consistent system that is dependent has infinitely many solutions. A system of equation that has no solution is inconsistent. So if it has a solution, at least one solution is consistent. If there's exactly one solution, it's independent. If there's more than one or infinite number of solutions, it's dependent. So go ahead and see if you can fill in these, reread that to help you do that. All right, so we want to define each of these systems using that information. And so we want to graph them. Now, to graph, you really just need 2 points, but sometimes it's easier to graph it there in a certain form. So let's change the form of this one right here by dividing both sides by 3. So remember, this is 1x now. So we get y equals 1/3 x minus 2/3. All right. So we have a point at negative 2/3 on the y-axis. And since we have negative 2/3, let's make our scale be 1/3. So that might help us out a little here. So our slope is, our y-intercept is negative 2/3. That's right here. And our slope is 1/3. That means I go up 1/3. All right. So there's one line. And that looks like that. All right, and our other line, we can get that by just dividing both sides by -6. And if I do that, I get y equals -2 divided by -6 is 1/3 x. 4 divided by -6 is, if I simplify that, that's -2/3. Now when I graph that, that's the exact same equation. We are going to end up with a system that where one line is right on top of the other line, And so this is a consistent and dependent system. And there's an infinite number of solutions. All right, you want to try that with system B here? Actually, we'll do this one together too. So the y-intercept for the first equation is -6. Let's put a dot there. And our slope is 5. So we're going to go up by 5. So there we go. Draw that line in. And that looks like that. And then our second equation has a y-intercept of 4 right there, and a slope of 5 again. So we'll go up 5 over 1, put that in, and we'll draw that line. Different color. All right, and that one looks like this. And we can see that our two lines seem to be parallel, which makes sense because they have the same slope. When that happens, we have an inconsistent system, and there is no solution. All right, you try that. All right, here we are at the lesson check. Go ahead and do this, and we'll talk about it next time we meet in class.